on Monday the 16th. Hope you guys had a good weekend, and hopefully you received all my emails with your latest grade updates. Your quiz should be, well, we'll get to that in a second, but your quiz was emailed to you, and I emailed your parents also all of your grades so far. So I've said this once, I'm going to say it all year long until you get tired of hearing it. You've got my number, you should. Let me get on black ink here. 706-965-2675. And I know you guys have my email because you guys email me all the time. So call or email if you have any questions and I can help you, okay? Let's start off with some announcements and then we'll get right into today's notes. Like always, I will go fast. That way those that are getting it can move on and those that aren't can pause the video and back it up. There will be a test next Monday, so a week from today you'll have a test. You'll be at my house unless you choose not to. And so we will have a review sheet this Friday. I think it's around 50 problems. I believe it's already written up, but you'll have 2 days to do it like usual, so it's very reasonable. Next announcement, be working on your integrity sheets. Remember, men, they will give you, they are the integrity sheets. Remember, the integrity sheets will give you 5 bonus points on your next quiz. 5. I mean, that's really, really, really important. And so 3 out of you 4 men did all of your assignments on all of your integrity sheets. So good job. That means on your next quiz coming up, not the one you just took, but the next one coming up, you will have 5 bonus points. So that's a good job. Moving on, number 3, if I haven't heard from you about your quizzes that are due today, that you need to be doing something. It says do some. That should be some right there. Do some communicating. So please take care of that. And let me know what's going on with your quizzes. Okay? Hope that takes care of the announcements. Grab your notebooks, papers, pencils, calculators, books, and let's roll. We're going to look at many things today. We're going to start off by looking at standard position of angles. Standard position of angles, the lesson number is 5.3. And again, if you keep track of the date is the 16th of September, 9/16/13. So we're looking today at something called standard position of angles. Now, I would not write this down, just listen to me. Being able to write angles in standard position is very, very, very important. It is the foundation for being able to solve for trig functions of angles, that are negative and or that are larger than 90 degrees. And if you cannot write an angle in standard position, you're not going to know what this means, but trust me, you're not going to know what quadrant you're in, so you're not going to know what sign to use, positive or negative. And so writing angles in standard position is very, very, very important. Now, let's go ahead and do this. I want to draw some angles in standard position and give you some terms and also let you look at some negative angles. So if you would in your notes, go ahead and draw a coordinate plane. Here's your y, here's your x-axis, here's your, make that x, here's your y, here's your x. And notice, I'm going to go ahead and put a dividing line right here. Notice that I've numbered your quadrants for you. Let me change that real quick so there's no confusion. There we go. All right, so we have quadrant 1, 2, 3, and 4. 1, 2, 3, and 4. You need to memorize those and know those. They are very, very, very important. Know your quadrants. They start in the top right corner and they go counterclockwise. Remember that and you'll be all set. 1, 2, 3, 4. 1, 2, 3, 4. Now, when I ask you to draw an angle in standard position, here's what I mean. Please take some notes here on your first coordinate plane. First of all, that means the vertex of the angle has to lie on the origin. And it also means that the first angle side that you draw has to lie on the x-axis. So if you're going to write an angle that is in standard position, then it lies on a coordinate plane. The vertex is at the origin 0, 0, and this ray lies on the x-axis. Okay? Now, let me give you a term for that ray right there. Hold on one second. It is called the initial side. If you want to make note of that, you really should, because we're going to use that term a good deal. You need to know this first ray that you draw that lies on the x-axis is called the initial side. All right. Now, let's say then you draw the rest of the angle like this. Let's say it goes right there. All right. So there's your angle. I draw an arrow like that telling you what direction the angle is going, and there's your angle. Now, that angle is, oh, by the way, before I say something else, this is called your terminal side. You need to know that. So where the angle stops is called your terminal side. Again, you need to know that. So this ray here is called your initial side. This ray here is called your terminal side. Now, men, listen to me, please. This angle is drawn in standard position because the vertex of the angle is right here on the origin, and your initial side is on the x-axis. That's all you have to have. And then you simply draw your angle, okay? Now, any angles that go in a counterclockwise movement like this, those are positive angles. So today we're going to start getting into, yes, negative angles. And a negative angle just means a direction. It does not mean anything else, okay? So a positive angle would start here on the x-axis, and it would rotate up and around to the left, okay? And by the way, again, the angle could be drawn all the way to here. That would be okay. It doesn't really matter where it starts or where it stops, excuse me, as long as it starts on the x-axis and goes upward and to the left. That would be a positive angle written in standard position. Now, on your other coordinate plane here, I would like to give you a picture or a drawing of an angle drawn in standard position, okay? But it would be a negative angle. So let's go ahead and draw your ray right there. And then we're going to rotate this angle down like this, and we're going to have it stop right here in the second quadrant. No certain reason. That's just what I felt like doing. So notice this angle goes from here to here. So that would be a negative angle, okay? That is a negative angle written in standard position. I know it's negative. In fact, looking at this, let's see, watch this carefully. You ready, guys? Watch my pen. From here to here is 180 degrees. We know that because we have from here to here is 90. From here to here is 90 more. And then it looks like about 45 more. So I would call that about, this angle would be negative 215 degrees. 90, 90, and about 45 more. Is that right? No, I guess that'd be 225, excuse me. 225, okay? All right, this angle here, I would call this about 115 degrees because it rotated 90 and then about 25 degrees more, maybe a little less, maybe 110 degrees, okay? So when I asked you to write an angle in standard position, this is what I'm talking about, and you need to be able to do that. Now let's move on and work some problems here. I want you to write this sentence in your notes. Take the following angles and determine what quadrant the terminal side lies in, okay? So I want us to figure out what quadrant the terminal side lies in. So let's remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So the first angle they want us to draw would be 127 degrees. So I'm going to go ahead and start here like I would always do. And by the way, in your notes, take notes how you want to. Okay, that's up to you. But 127 degrees. Well, I know if I go all the way like this, that's 180. That's way too far, okay? So, and I know from here to here is 90, so I know I've got to go further than that. So I really don't care if you get the drawing perfect. All that I want you to see is you would stop somewhere here. Sorry about that, my computer's messing up. You would stop somewhere here. I'm just going to guess. And so that's approximately 127 degrees. So this is the initial side, right? Okay. This is the terminal side, right? Yep. What I'm asking you is what quadrant does the terminal side lie in? Well, here's your terminal side, and it's lying in quadrant 2. So the answer to number 1 would be quadrant 2. All right, let's go ahead and see. I'm going to go ahead and erase these quadrant numbers. They're not going to stay. All right, now let's go ahead and draw 39 degrees. Well, I know if I go all the way to here, that's 90. That's too far. So I'm going to guess 39 degrees. It's probably about right there. So there's 39 degrees. So I know the terminal side. I'm going to do it in blue here. Here's the terminal side right here. There's the terminal side. And it's lying in quadrant 1. So the terminal side for 39 degrees lies in quadrant 1. Now let's hold on a second. My computer is malfunctioning like usual. So hold on one second, please. Uh-oh, not good. Okay, let's continue here, class. I think I've been able to salvage the video so far. The colors here are a little different. But anyway, let's continue on. So, and as you get pretty good at this, men, you will not have to draw the coordinate plane. You can just picture it in your mind, okay? All right, let's find out what quadrant the terminal side lies in for 349 degrees. So I start here. I go here. That's 90. Let me go and draw my initial side. There we go. Start here. There's 90. 90 more, that's 180. 90 more, that's 270. But if I go all the way around, that's 360. I know that's too far, so I'm going to have to go to about, about right here. Looks pretty good. Again, it doesn't have to be perfect. I just want you to see what quadrant you're in. So 349 degrees, this is quadrant number 4. 349 degrees has its terminal side lying in quadrant number 4. And now let's take a look at number 4, negative 210. This is interesting, guys. This will be a first time for this. So we start here and draw our initial side, and then we rotate down because it's a negative angle. If it's positive, we rotate up. If it's negative, we rotate down. So negative 210, so I go 90, and then 90 more, that's 180, then 30 more degrees. So there's negative 210 degrees, and it looks like that lies in quadrant 2. So your terminal side lies in quadrant 2. It's really important you know how to do that, and you're going to find out tomorrow, contain your excitement, on why that's so important when it comes to solving trig functions for angles larger than 90 and also negative angles. All right, let's continue on. Now, we're also going to take a look now at coterminal angles. We're still on lesson 5.3 if you want to make note of that. But we're going to take a look at a lot of little topics today, guys. Okay, so get ready for that. It's not going to be a video that's any longer than usual, but we're going to look at a lot of small topics. So let's take a look now at coterminal angles. So before we jump into this, we need to completely understand a couple of things, all right? Now, you don't need to write these down. Just listen. Number 1, coterminal angles are just angles. Actually, I do want you to write that down. Coterminal angles are just angles, okay, listen carefully, that have the same initial and terminal sides as another angle. Coterminal angles are just angles that have the same initial and terminal sides as another angle. That's all that a coterminal angle is, okay? Number 2, you need to write this down too. There are infinite amounts of coterminal angles. Infinite amounts for a given angle. Infinite. Number 3, you don't need to write this down if you don't want to. If you don't master how to find coterminal angles now, I can guarantee you will be lost later. So please listen well. This is very, very important. All right? Okay, let's jump into this right away. I want us to learn right away how to draw coterminal angles of a given angle. Now, as you get better at this, then I have no problem with you skipping the step of using the coordinate plane. But for right now, let's use a coordinate plane so you get a really good picture of how to draw or how to find coterminal angles. Now, the first one we're going to deal with is 26 degrees. Now, watch what I do. I'm going to go ahead and estimate my 26 degrees, okay? Everybody got it? 26 degrees. Very good. Now, that's the angle I gave you. Now, if I said, students, write a coterminal angle for 26 degrees, okay? You start here. Don't miss that. You start on the same initial side as the 26 degrees. And then you rotate like this. You go around one whole time. That's 360 degrees. And then you keep going until you come to the coterminal side. Let me go over that again. When I ask you to draw a coterminal angle, you always start at the same initial side. That's easy, guys. It's easy. And then you go and you circle around once and then stop when you hit the terminal side. And I'm sorry about that, guys. I'm still on the a different mode. Let me fix that. So around and there. So here's the coterminal angle. Are you ready? Watch. You went around once, and we know that's how many degrees? 360. And then you went 26 more. So you add 26. So a coterminal angle would be 386 degrees. So one coterminal angle for 26 is 386. Isn't that cool? Now let's try this again. Let's try this again. Watch this. Now let's find another coterminal angle. Another one, Mr. Yeah, watch. Go around once, and then go around again. That would be 360 plus 360, and then go right there and stop right there, 26. So we would have 746 degrees. Remember my comment back here, guys? There are infinite amounts of coterminal angles. Now you're seeing why there's infinite amounts. You can go around as many times as you want to find a coterminal angle. You could start here and go around 1, 2, 3, 4 times, as long as you end on the terminal side and as long as you start on the initial side. Every time you go around, it's 360 degrees. Now, how about a negative coterminal angle? Watch this. I start here, that's the initial side, and I circle around and I stop there. Hey, that works, guys. There's nothing wrong with that. I started here on the initial side and I went down and around. Did I not start on the initial side? Sure I did. Did I not stop on the terminal side? Sure I did. So I went all the way around and stopped here. So I almost went 360 degrees, but I was 26 degrees short. So I'm going to take 360 minus 26, and I would get 334 degrees negative. Don't forget, we went down and around. So another coterminal angle would be negative 334 degrees. There we go. And my computer's messing up again. Hopefully it'll work in a second. There we go. All right. So really, I mean, there's just a lot of different answers, guys. As long as you start on the initial side and rotate to the terminal side, you're fine. There could be a negative. You could start here and go like this. Go around once. That's 360. And then go around here and stop right there. As long as you start on the initial side and end on the terminal side, it doesn't matter. And we're not going to figure all that out, but you get the idea. So let's do this. Let's find a positive coterminal angle. I'm going to real quick, I'm going to go really fast. I'm going to find 2 positive coterminal angles for this one, and then I'm going to find 2 negative coterminal, there we go, 2 negative coterminal angles. So the first thing I'm going to do, if I can get this thing to work, hold on one second, and delete, there we go. Now, I'm going to go ahead and draw 115 degrees. It's always good to get a picture of it. So there's my initial side. I rotate 90 plus about 25 more, and there we go. Okay? Now, that is 115 degrees. All right? Now, I want us to find 2 positive coterminal angles. So here's my first one. Are you ready? I start here. I go around once, and then I keep going until I hit the terminal side. Boom, I hit it there. So I went around once. That's 360 degrees, and then plus 115 more. So one positive coterminal angle would be 475 degrees. All right? Now, let's see if we can't continue this. Another positive, actually I want to leave that there, so I'm going to put that back up. 475 degrees. Now, let's get another positive angle. So I would start here. I would go around once, and then go around again. So that's 360 and 360, that's 720. And then I would stop on the terminal side. That's 115 more degrees. So 115. So 835. 835. Now let's find 2 negative angles. All right, let's find 2 negative coterminal angles. So we start here, and we rotate until we hit the coterminal side. There we go, and there we go. Look at that. All right, so I can stop there. That I don't have to go around one whole time because that's already a different angle. I didn't go 115 degrees, so I didn't quite go 360. I stopped 115 degrees short. So 360 minus 115 would be 45. 245 degrees. So there's one negative coterminal angle, negative 245. Now let's find another one. We start here, go around once, that's 360, and then we go around that many degrees. So we know we have 360, and then we already know from doing this before, I go around once is 360, then from here to here is 245. 605 degrees. Now it'd be negative because we went down and around, but it'd be negative 605 degrees. Now I'm taking too much time on this part of the video, so I'm gonna shorten this up and do this. I'm gonna just do a negative 250 right here. So go ahead in your notes, make that negative 250, and go ahead. I want you to find one positive coterminal angle and one negative for this, then we're moving on. I'm not going to do a fourth problem. Okay, let's first of all draw this angle, negative 250 degrees. So I rotate 90, 180, and then 70 more degrees, so about right there. And then draw my angle, and that whole angle would be negative 250. Now, students, please watch what I do. I want you to find a positive coterminal angle. So I start here, and I rotate to the terminal side. Boom, right there. That's all I have to do. So I know if from here to here is 250, then from here to here would be 360 minus that 250. So it's got to be 110 degrees. Okay? So I know a coterminal angle for negative 250 is 110 degrees. Now I want you to find a negative coterminal angle. We'll do it in green, a negative. So I start here on the terminal side, okay? And I know I can't stop, or excuse me, I start here on the initial side. I know I can't stop here because that would be negative 250. So I've got to do one whole lap. That's 360. And then I go 250 more. So I did negative 360 and then negative 250, negative 610 degrees. You need to back this up and listen to it again if you're confused, guys. You have to know how to find coterminal angles, or it's really going to be tough. Okay, this is a fundamental you definitely have to know how to do. Okay, let's continue on. I'm going to go through this relatively quickly, students. I don't want to be rude to you, but this is really easy math here, so I'm not going to spend a lot of time on this. When I tell you, you'll want to write these two sentences down. When I say we have complementary angles, that means you have how many angles? 2 that add up to what? 90. So if I said one angle is 70 degrees and I said what's the complement of that angle? The complement of that angle would be 20, because 70 plus 20 is 90 degrees. If I gave you 100 degrees, now think about this, and I said what's the complement of 100 degrees, you would say negative 10 degrees, because 100 degrees and negative 10 would be 90 degrees. Okay, so I do expect you to know how to do that. It's pretty simple. Just simply making sure two numbers add up to 90 degrees. Now, if we say that two angles are supplementary, and how many angles? 2, and we say they're supplementary, that means the two angles have a sum, or they add up to 180 degrees. So if I said to you, one angle is 50 degrees, and I said, what's its complement, like we just studied? Well, the complement would be 40, because 50 plus 40 is 90. But what if I said, what's the supplement of 50 degrees? You would say 130, because 50 plus 130 is 180, okay? If I said, what is the supplement of 210 degrees? Well, obviously, you would say negative 30 degrees, because 210 degrees plus negative 30 gives you 180. That's really simple. Moving on, that's pretty much elementary math there. But complementary angles are two angles that add up to 90. Supplementary angles are two angles that add up to 180. I just want to make sure you guys know all this stuff. All right, now let's take a look at reference angles, and I'm pretty sure, let me glance ahead here, I'm pretty sure that's it for the class period. Yes, so write this down, please, reference angles. And if you don't master finding reference angles, you will struggle with finding trig functions of certain angles. You have to be able to find coterminal angles, you have to be able to draw angles in standard position, and you have to be able to find reference angles. I love y'all enough to tell you the truth. If you can't do that, you're not going to understand what we're going to do tomorrow. So you need to master this today. Make sure you understand the difference between coterminal angles, reference angles, angles in standard position, and complementary and supplementary angles. Might not be fun, but you have to know that, okay? All right, so write this down. Reference angles, lesson 5.3, and go ahead and write this down. You don't have to write this sentence. I'm just kind of saying that to myself here to see things to say to you, but I'm going to give you some examples of how to find a reference angle. So you're going to have to draw a coordinate plane, and I'm going to give you some examples, and we will get after that right away. So here we go. Okay, the first thing I'd like to do, students, I paused the video there. Whenever you see the mouse go like this and click on that, and I click on recorder, I'm pausing. I just thought of a sentence I want you to type in your notes. I think it's real important, okay? So I do want you to write this down. And I'm usually very prepared, you know that, but I got thinking, I think this sentence would help you a lot, so please write this in your notes. A reference angle is the angle that is formed between the x-axis and the terminal side. Now, man, that's real important, okay? That's just really important. If you want a definition of reference angle, there it is. A lot of you like side notes, and here it is. A reference angle is the angle that is formed between the x-axis and the terminal side, okay? So with that in mind, let's go ahead and get started. I want you to find the reference angle. Here's our first problem we're going to do. Are you ready? Find the reference angle for 63 degrees. Okay, let's go ahead and first of all draw the angle in standard position. That's always very important to do. 63 degrees would be about right there. Okay, so there's my 63 degrees. There we go. Now, I told you that the reference angle is always the angle that's formed between the terminal side and the x-axis. Well, guys, here's the x-axis right here. Here's the terminal side right here, okay? And I probably should say this. It's the acute angle, because technically you could say this. You could say, oh, here's the terminal side right here, and here's the x-axis over here, so here's your reference angle. No, it's got to be the acute angle, so I should have written that in there. But if you'll look right here, the reference angle for 63 degrees is, are you ready for this? 63 degrees. That's easy. I mean, that's not hard at all. I mean, look, what is the angle that runs from the x-axis to the terminal side? 63 degrees. So the reference angle for 63 degrees is 63 degrees. This'll start sinking in. Let's try another one. Let's try 125 degrees. Okay, let's go ahead and draw our angle in standard position. So I go 90 and then 35 more there. So 135 degrees. Do you see it? So what is my reference angle? Well, look at your definition. The reference angle is the acute angle that's formed between the x-axis and the terminal side. Okay, I'm going to get some blue. All right, here's your terminal side right here. And here's your x-axis right here. Hold on, my computer's freezing up. There we go. So what angle is formed right there? Let me go over that again. I don't think some of you have seen this. Let's go over it again. The reference angle is the acute angle that's formed between the x-axis and the terminal side. Okay, here's your terminal side. Nobody would argue with me there. That's obvious. That's your terminal side. And here's the x-axis here. So question mark. What angle is formed right there? Well, think about it, guys. If we go from here to here, that's 135. If I went from here all the way to here, that's 180, right? Well, I don't want 180. I've got 135 missing. So I take 180 minus 135, and you'll get 45 degrees. So this angle right here is 45 degrees. 45 degrees. There it is. I mean, think about it. This is 135, so this has to be 45 because they have to add up to 180. Let's try another. Let's try a bunch of them, and hopefully you'll get this, okay? All right, number 3. Let's find the reference angle for 260 degrees, all right? So I'm going to go ahead and draw it in standard position, 260 degrees. I go 90, then 180, and then 80 more would give me 260. So there we go. There's my 260 degrees. Now, what is my reference angle? Here's your definition. The reference angle is the acute angle formed between the x-axis and the terminal side. Well, here's your terminal side right here. You guys wouldn't argue with me there. And here's your x-axis right here. So you've got to find that angle right there, question mark. Guys, it's not that hard. Come on, watch this. Think about this. Hold on, my computer's freezing up again. If it shuts down again, it's not going to be good. All right, there we go. All right, now think about this. This is not very hard. We know, I'm going to switch colors. We know that the whole angle all the way around is 260. So we know from here to here is how much? 180. So if from here to here is 180, then take 260 and minus 180, I'm left over with 80 degrees right here. 180 plus 80 is 260. Think about that. From here to here is 180. So from here to here has to be 80. So my reference angle for 260 is 80 degrees. All right? It's really not too hard. All right, let's try one more. Let's try two more. We're going to try a negative angle, and then we're done. All right, let's try 330 degrees. So first of all, draw the angle. So we go 90, and then 90 more, and then 90 more. That's 270, and then 60 more. So there we go. That's 330 degrees. Now, find the reference angle. Well, what is the reference angle? Well, it's the acute angle formed between the x-axis, here's your x-axis, and the terminal side. Here's your terminal side. So it's that angle right in here, question mark. So if from here to here is 330, then I know this little bit right here has to be 30, because 330 plus 30 gives you 360 all the way around. So your reference angle is 30 degrees. Do you see how easy it is, men, to get confused with reference angle and coterminal angle? You have got to make sure you have these down pat. One more and I'm finally done putting you guys to sleep. Let's try a negative angle, all right? So I'm going to go ahead, and I hope you're taking really good notes on this. You need to. Let's say negative 200 and, I don't know, 200 and just 200, negative 200 degrees. All right, I want you to find the reference angle for negative 200, all right? Well, we draw our initial side, and then it's negative, so we rotate down. So we rotate down 90, and then 90 more, that's 180, and then 20 more degrees. And I draw my angle. There you go. That's negative 200. Now I want you to find the reference angle. Well, the reference angle is the angle formed between the terminal side, there's your terminal side, and the x-axis. So that little angle right there, question mark. Now think about it, guys. From here to here is 180. And from here to here all the way around is 200. And so from here to here is 180. Then this little angle right here must be 20 degrees. Because 180 plus 20 more would give you your full 200. I really hope that makes sense, guys. Please, please do your homework. Look, I cannot imagine not doing your homework and not checking your answers in the back of the book. That would make really, really no sense to me. I'm not being mean. Please do your homework and please check your answers in the back of the book. Now, I want to show you some stuff you need to know. First of all, notice you do 1 through 23 odd. That's pretty normal. But look at this. 41 through 69, every other odd. That means you do 41, skip 43, do 45, skip 47, do 49, skip 51, do 53, skip 55, do 57, etc. Notice you're just adding 4. So you would do 41, add 4, do 45, add 4, do 49, add 4, do 53. That's the first thing I want you to notice. I want you to know what EOO means, every other odd. Secondly, when you get to these EOO problems, don't do what all the directions state. Just find the reference angle. Okay, that's all I want you to do. So when you turn to page 471, like I'm doing right now, the very first problem looks like this. I'm going to write it for you. The very first problem looks like this. It says find the tangent of negative 135 degrees. Forget the tangent. All I want you to do is find the reference angle of negative 135 degrees. That's it. That's all I want you to do, nothing more, okay? So please call me or email me if you have questions on that. Have a great rest of the day. Please do your homework, and I will talk to you guys tomorrow.